All right, good afternoon again, everyone. For today, we'll start our discussion of the coverage of Math 155. So hopefully you already have a copy of the lecture notes, so you can download Unit 1 and Unit 2 um, lecture notes from our Canvas website. So puntahan nyo lang siya sa Canvas. I guess for those who don't have a Canvas account yet, or those who were accepted via pre-rog na wala pang UP email, I sent the Unit 1 along with the modules for week 1 to you guys. So please check your emails. If you didn't receive any email from me, then please let me know. Chat nyo lang ako sa MS Teams or sendan nyo ako ng email saying na hindi ko pa nasa-send sa inyo yung materials. So, and then for those who cannot access Canvas yet, so you can send your homework via email. So, ganun din yung deadline. So, kaya lang maging iba lang yung modality for your submission. And then if you are done with the homework and you feel na okay na to, eto na talaga yung final answer ko, don't hesitate to submit homeworks ahead of the deadline. There are several advantages to it. Kasi allergic ako sa mga notifications. So pag may pulang notif kay Canvas, gusto ko na talaga siyang checkan. So once I receive a submission at kung ako naman ay free, I'll try to grade it as soon as I can. I won't wait until the deadline. Hindi ko antay na lahat ay makapagpasa. But hopefully you guys won't abuse the process. So kung na-checkan ko na yung papel nyo, kahit hindi pa deadline, do not share it with your other classmates, yung feedback o yung score nyo. So sa inyo na lang muna. And then once your classmates' work were already graded, you can compare your notes and so on. So para gusto ko kasi maging immediate yung feedback. So kasi pag-aantayin ko yung deadline, bago ako mag-start mag-grade, ay posibleng tumambak na yung submission. Matatagalan ako ng pagbabalik. So gagawin ko ay once I receive a submission and if I am free, I'll start grading them para maging immediate yung feedback. And may isa palang disadvantage yung setup natin kasi I will leave the homework submission bin open until 1 week after the deadline just to give some leeway for those who cannot meet the deadline, all right? So, hindi ko siya madi-discuss the following week kagad para for the benefit of those who are still working on it. So, ano kaya pwede nating maging remedy doon? But again, if you submitted your work, you will receive individual feedback. But of course, I might have some comments regarding or about some misconceptions or about something that is common mistakes among the class. Hindi ko siya ma-discuss kagad following the homework. So, ano kayang posible pwede natin gawing remedy doon? Or sa tingin nyo ba magiging enough na yung individual feedback? Or wala pa kayong pakialam doon sa ngayon? So yeah, probably let's talk about that later. If you think of something or a good, clever suggestion about that, then that's perfectly fine. So, but I am putting my entire trust to you guys. You will be faithful to the declaration you signed in homework 0. Okay. So let's start. Let's take a look at Unit 1, which is basically the real numbers. As I mentioned last time, Math 155 is pretty much a reconstruction of the calculus we learned in Math 36, 37, 38, probably not 38 because that's multivariate, that's for Math 156, but also those things that you have been using since your senior high school. So here we will have a rigorous treatment of calculus and actually starting from the real numbers because calculus is founded on the idea and the nice structure of the set of real numbers. And that's why we are starting unit number 1 with the set of real numbers. So if you look at the lecture notes, you'll see 9 sections for this chapter. And hopefully today we'll be done with section 1.1. Okay. Now moving on. Okay, let's start. Algebraic axioms. So do you guys remember what an axiom is or how different an axiom is from, say, a theorem, a lemma, or a remark? Review ng 101. Anybody? You can just unmute yourself or comment in the chat box. Yes, Donnie?
Hindi pala ako na-mute. Oh. Sir,
Sorry.
yung
Mhm.
action po ay statements na hindi kailangan ng proof, unlike theorems na kailangan ng proof.
Exactly. Great. So, ibig sabihin, masaya kayo kapag puro actions ang nasa readings. Kasi these are self-evident roots. These are the assumptions for the mathematical discourse. And she's right. Hindi kailangan ng proof kasi ito yung magiging foundation ng buong logical discussion natin. So, these statements do not need proof. They will be assumed to be true for the sake of what is to follow. All right? Of course, there are some criteria for a good axiomatic system. So basically, you want your axioms to be minimal. Konti lang dapat yung axioms na ilalagay natin. Number two, they should be consistent, meaning no two axioms will contradict each other. And then we have also the idea of having a complete axiomatic system, meaning all theorems must be provable using the elementary axioms and results therefrom. Kaya lang, binasag ni Gödel yung ating search for a unifying mathematical system. Sabi ni Gödel, na-prove niya na walang nag-exist na consistent and complete axiomatic system. So kung consistent yung axiomatic system mo, hindi siya pwedeng maging complete, meaning not all results might be provable. But of course, as mathematicians, we'll try to do our best to develop a nice axiomatic system. So what we'll try to do is construct an axiomatic system based on consistent axioms or assumptions. All right. Oh, I forgot another important thing about axioms. Axioms must be independent. So independent siya in the sense that no axiom can be proven from other axioms. So kung meron kang axiom 1, axiom 2, si axiom 1 di mo dapat kayang i-prove using axiom 2. And so on. So if you have 7 axioms, no one of them should be provable using the other 6 or combinations thereof. Kasi gusto natin maging minimal. So kung ganun yung axiom o ganun yung statement, pwede mo na siyang ibaba as a theorem because kaya mo naman siyang i-prove using the previous axioms. So basically, yun, that's the idea of axioms. So we always start any mathematical discourse from undefined terms. For instance, for our case, we will accept the set of real numbers to be an undefined term. So ano yung konsepto ng number? Ano yung konsepto ng real numbers? We will tacitly assume that we have a common notion of real numbers. So parang natural object siya nung discussion. And then of course, once you have the undefined terms, we're going to go to axioms. And here we are laying the foundation for our mathematical discourse by specifying some axioms about the real number system. But when we say the real number system, we say that this is a collection of objects called the real numbers. Again, isa yung konsepto na i-assume ko na common na alam nating lahat. The usual notion of real numbers. And then we shall denote it by R, or the double struct R. Pag handwritten ko yung R na real number, ganito ko siya sinusulat. So meron lang double bars sa gilid. And we assume it is equipped with 2 binary operations called addition and multiplication. Now, it might be too much to ask, but I will ask you, at least for this hour, 4:30 to 5:30, you first forget what addition and multiplication is. Kalimutan niyo muna yung properties ng usual addition and multiplication that you know before. Aside, of course, from the axioms or the properties that we will specify. So we'll assume, or I will invoke, the meta-axiom of ignorance, and that's common in any mathematical discourse. So when we say meta-axiom of ignorance, you only know what is given, what was previously defined, and what are proven. Of course, aside from prerequisite topics, okay? So, ibig sabihin ngayon, kahit alam niyo na sa elementary na halimbawa ang 8 times 0, real number times 0 ay 0, I will not believe that for now kasi binura ko yung idea ko ng properties ng real numbers. Nire-reconstruct ko siya from the beginning. So, until we have proven that 8 times 0 is equal to 0, then I will say, I don't know what 8 times 0 is, okay? So sana clear yun. Yun yung magiging basis natin para dito. And that's why you will see in the beginning, I will be very particular with specifying all the properties of R, even if we had been using them since our elementary days. Okay? Now let's see some of the properties. I hope sufficient yung size nung lecture notes. Nag-isip pa ako kung ano yung okay na format. Kailangan ko pa ba siyang isulat as a beamer or a slide presentation, or I'll just annotate over the lecture notes. So let me know what you think about these approaches. We can try several approaches during the semester at tingnan natin ano yung good mix for us, okay? Now, in the lecture notes, all axioms are labeled with A and then followed by a number, okay? So you see here, A1 to A4 are 4 axioms that we will assume for addition. So for now, yung notion ng addition and multiplication is an alien notion to us. Hindi natin alam paano nag-add ng dalawang numbers, paano multiply ng dalawang numbers. So we are beginning from a clean slate, all right? So all we know is that addition and multiplication are binary operations. We take 2 real numbers, we can operate on them. If we add them, we get another real number. When we multiply 2 real numbers, we get another real number. That's what it takes to be a binary operation. Baka na-encounter nyo rin siya sa 111, but that's what a binary operation is. Now, we don't know anything about it until I introduce these 4 axioms or properties, okay? Property number 1, addition is commutative, right? That means the ordering of the numbers under consideration for addition is immaterial. So if I write A plus B, that's the same as B plus A. And then from now on, you can use commutativity. Associativity is the grouping property. So it doesn't matter if we add A plus B first and then add C to it. We'll get the same result if we add B plus C first and add the result to A. Okay, so associativity. Simula ngayon, pwede nyo nang gamitin yung associativity kasi na-assume ko na siya as an axiom. All right? And then axiom 3 is the existence of additive identity. That means there is a real number added to another real number will give us the second real number. And in this case, we will denote the additive identity to be 0. So that means 0 is the only real number that when added to another real number will give me the second real number, right? So A plus 0 is equal to A, but also by axiom A1, addition is commutative. So if A plus 0 is equal to A, then 0 plus A must also be equal to A, right? So we call that the additive identity property of 0. And then aside from that, there also exists an additive inverse for any real number A. So, and then that real number is unique. So if you have a real number A, there will exist exactly one real number, and we will denote it by negative A, such that when added to A, okay, so A plus the negative of A, and we learn from axiom A1 that if I reverse the order of the addends, I should get the same answer. Hence the equality there. And the beauty about additive inverse is that when you add two numbers that are additive inverses of each other, you get back the additive identity. So yung A plus negative A, kasi sabi ko si negative A ay additive inverse, ibig sabihin pag in-add ko siya kay A, ang sagot ay 0. Okay? Now, alam ko medyo mahirap itong tanggapin, sir, bakit mayroon pang mga ganyang assumptions or bakit may mga ganyan pang theorems? Because we already know that A plus negative A is equal to 0 since elementary, right? Or since we learned negative numbers. But the idea here is we don't know how addition works. We don't know how the numbers look like. The point here is we are rebuilding everything from scratch, okay? So that means negative A is not the usual negative number so far na alam natin before. So at our current state in Math 155 ngayon, we don't know the number negative 1 as a number on itself. Yung negative 5, hindi yan yung negative 5 na alam na natin before. Kasi yung negative 5 per our notation means the additive inverse of the number 5 or the real number 5. And that's all we know. We don't have a notion of what negative 5 as a number is. We only know that that's the notation for the additive inverse of 5. And what's the property of additive inverse? Kapag ka si 5, inad ko sa negative 5, ang sagot, yung additive identity, which is 0. Okay? Clear ba yun? Usually, ito yung medyo mahirap tanggapin kasi ito yung mga pinaka-basic. Pero nire-relearn natin silang lahat. Okay? Everything's fine so far? Or ayaw yung tanggapin? Ayaw yung kalimutan yung addition na alam natin from elementary? Or nandyan pa ba kayo, guys? Pwede nyo gamitin yung reactions ni Teams if you want. So, yeah. Questions so far? Wala naman? Nasa meeting pa ba ako? I think so kasi gumagalaw naman yung screen ko sa laptop. Okay. Now, we'll do the same thing for multiplication. So we'll enumerate those properties that we want to assume in the second binary operation we defined on the real number system. So we have axiom 5, commutativity of multiplication. We can reorder the factors being multiplied. Okay. In the same manner as addition, multiplication is also associative, meaning the grouping doesn't matter. Kasi di ba binary operation siya, so ibig sabihin binary, dalawahan lang at a time ang pwede nating i-multiply. If you have 3 numbers that you want to multiply, it is necessary that you group those numbers by 2s muna before you perform the operation. Luckily, multiplication is a nice operation, or is assumed to be a nice operation, because the ordering or the grouping doesn't matter because of axiom 6. Okay. And then axiom 7, existence of additive identity, meaning there is a real number when multiplied to a real number, say A, will give us back the real number A. So na-preserve ni 1 yung identity ni A. So first typo for the day. So this should be a multiplicative identity. Nakaligtas siya nung pinu-proofread ko, so sorry about that. So kindly correct also your notes. So yeah, A7 is the existence of a multiplicative identity for multiplication. Okay? Now again, hindi natin alam kung ano yung real number na yon. Basta alam natin pag minultiply ko siya sa kahit anong real number, ang ibabalik niya sa akin ay yung real number na yon. So by notation or by convention, we decided to call that multiplicative identity the number 1. Okay? And then A8 is almost a mirror of A4 because it's also the existence of a multiplicative inverse for a real number, but may exemption. Hindi lahat ng real number kailangang merong multiplicative inverse. In fact, any real number except the additive identity will have a multiplicative inverse. So that's why you have a restriction here that if A is not the 0 element or is not the additive identity, then we can find a unique real number denoted by A inverse. So for now, we don't have any notion of fractions. We don't have any notion of negative exponents. So, but here, A to the negative 1 is simply a notation for the multiplicative inverse of a non-zero number A. And again, by definition of a multiplicative inverse, we mean that when we multiply 2 numbers who are multiplicative inverses of each other in whichever order, because anyway, multiplication is commutative, we get back the multiplicative identity. So this will work for any real number except the additive identity 0. All right. And then we'll have remark 1.1 after these axioms. We say here that for the multiplication, we will write either the concatenation of A and B. We'll just write them without spaces, or whenever necessary, I'll put a dot between the 2 factors instead of writing A cross B or A times B. So notations lang naman. And these are the usual notations we use for multiplication. And then di pa doon natatapos yung list of axioms natin. We have axiom 9, which is the first property that that is shared by multiplication and addition. Here we are saying that multiplication is distributive over addition. So if you are multiplying a real number and a sum of two real numbers, we can distribute the multiplication by A over the sum. So yung A na to, papasok siya dun sa product. So we'll have A times B plus A times C. Again, nothing spectacular with this 9 properties so far because we had been using this all our lives, right? Pero ngayon, pino-formalize lang natin. And the nice thing, as Donnie said, these are axioms and they do not require any proof. So from now on, you can appeal to A1 to A9 in writing your proofs kasi assume na sila to be true. All right? And then equality property. So here we are just formalizing what equality means. So we write the equal symbol as a logical notion, which as a logical symbol to mean is the same as. So we write A is not equal to B if A represents a real number, or in general, probably a set is different from another number or set B. So here we are also assuming some properties of equality. First one is the reflexive property. Second is the symmetric property. Third is transitivity. And the fourth is the addition property of equality. So probably we can call it the additive property of equality. So we can call it APE for short. So you can use this on your on any theorems as well. Actually, there's another property that we can add to this list. I don't know why it was left out. Pero siguro dagdag na rin natin. Property 5. If A is equal to B, then AC is equal to BC for any C in R. And this is the multiplicative property of equality. Hindi ko maalala kung pinrove to sa baba. So kung pinrove siya sa baba, tanggalin na lang natin. Pero for now, it might be useful if it is not proven below. So let's state that for right now. So the multiplicative property, you have two equal numbers. You multiply those numbers by the same quantity. You get back the same quantity. All right. And again, this is the usual notion of equality that we had been using since elementary. So nothing new about them. But again, since we have a meta axiom of ignorance, I need to state this explicitly. All right. Okay. Then we're done with 1.1. Any questions so far? Okay, I'll take that as a no. So let's proceed. Section 1.2, consequences of algebraic axioms. So here we'll start proving something. So siguro dito kayo magkakatanong. But first, let's define two new operations. But technically, these are not two new operations. Makikita nyo, notion pa rin siya ng addition and multiplication. It's just that we are introducing a different symbol for them. So for instance, naalala nyo kanina, sa ating system, meron lang tayong addition at multiplication. Pero nag-introduce tayo ng notion ng additive inverse at saka ng multiplicative inverse. Those numbers sometimes play a huge role in some results. So we are formalizing some notations for operations involving them. For instance, if I will add to A the additive inverse of B, which is denoted by negative B, right? So I can write it instead as A minus B. And this is what we learned in elementary as subtraction. So basically, subtraction is just addition in disguise, right? So nag-add lang tayo ng additive inverse nung subtrahen, okay? And similarly, if we have a real number not equal to 0, we can define division as the multiplication by the inverse of B, okay? So this is well defined because B is assumed to be a non-zero number. And so it will have a multiplicative inverse denoted by B to the negative 1. And we multiply it to A we can write it as A divided by B. And another notation for it is the fractional notation A over B. Okay? Paramdam nga kayo guys kasi super late yung nakikita kong annotation sa laptop screen ko. Naririnig niyo ba ako ng maayos? Or hindi?
Malinaw naman po, sir.
Okay. Delayed din ba yung yung annotation so hindi naman?
Parang sakto lang sa akin.
Sample nga. Ito, nagsusulat ako.
Opo.
Kaya nagsulat na ako. Hindi niyo nakita? Kasi hindi ko siya nakikita sa laptop ko.
Kita po sa akin, sir. Live dun po sa tabihan.
So, mukhang delay nga siya. Ayun, yun lang siya lumabas. So, anyway. So, okay. Good. Kita naman pala. So, baka sa laptop ko lang siya hindi nakikita. Alright. So, okay. Our first theorem for the class is Theorem 1.1, which is the cancellation law for addition. So, the statement is, if A, B, and C are real numbers, and A plus C equals B plus C, so we have two assumptions here. We're getting three real numbers, A, B, and C, and they possess a certain property. That property is A plus C is equal to B plus C. And then the cancellation law says that if that happens, then A is necessarily equal to B. So if you remember from Math 101, if you have an if-then statement, you can write a proof using a direct method, which is basically assuming the premise, the if part, and we'll try to use logical arguments in order to arrive at the then part, which is A equals B. And I guess that is what is done in the proof you see here. So you start with the assumption. It's a direct proof. So maybe I should that here. This is an example of a direct proof. We start with the assumptions or the premises given in the theorem. The then part of the theorem, the if part of the theorem says A plus C ay equal kay B plus C. So dito ako mag-start kasi ito yung assumption ng theorem. And then I'm going to use logical arguments, possibly using previous axioms or theorems, in order to arrive at the conclusion that A is equal to B. Okay? Okay, so let's try. So, okay, this is part of the premise. So I can start with this. Kaya sinulat ko na siya dyan. A plus C is equal to B plus C. And then I want to show, so we want to show, so ito yung mga usual na shortcuts na gagamitin ko. I'll write WTS for we want to show that, or ito yung gusto nating ipakita, A is equal to B. Okay? Now, I'll start with this. Tapos makikita ko, sobra ng C. Gusto kong matanggal yung mga C sa magkabilang side. So I need to think of tricks using axioms or previous theorems in order to get A equals B from this statement. So it's usually a good practice to always compare what you have so far with your goal or what is that you wanted to show, okay? So I want to get rid of the C's, but how do I get rid of the C's? Well, since C is a real number, it will have an additive inverse. So I'm planning ahead. Paano nga ba nawawala yung C? Paano ko mapapawala si C? Ibig sabihin, dapat maging zero muna siya. Paano nagiging zero, mag-add ka ng additive inverse. Tapos pag naging zero na siya, matitira nga lang ba si A? Yes, because A plus zero is equal to A. Because of axiom, what was that axiom? Yung axiom on the existence of additive identity, right? So that's the flow. Ayun yung parang magiging analysis. So here, again, I can get rid of the C if I will be able to add its additive inverse. And I know that the additive inverse will exist because C is a real number. And by, what was that axiom? Balikan natin. Yeah, the existence of additive identity, axiom 8.3, right? So sa A3, sabi laging may additive identity. Kailangan ko pala A4. Sabi sa A4, kahit anong real number may additive inverse. So since C ay a real number, meron siyang additive inverse. Ang tawag sa kanya ay negative C. And by the addition property of equality, if I start with two numbers that are equal to each other, I can add to both sides the same number. So here I added negative c to both sides. So this first line is justified actually by two things, by A4, which is the existence of negative c as a real number, and the addition property of equality. So yun yung reason behind the first line, okay? And then what happens to the next line? How do I get from this line towards this line? Anyone quick answer? Or ayaw nyo sumagot pag masyadong basic yung tanong? Dapat pala may recitation points, no? Para mapilitan kayong sumagot kahit madali. Okay, so there I used what? I used the associativity. Actually, may kulang pala, no? So dapat dito pakilagyan ng parentheses. Kasi di ba ang addition ay binary operation. So nag-add lang ako ng dalawang numbers. So I need to treat a plus c as a quantity on its own before adding to it negative c. Alright? Kasi binary nga siya, dalawahan lang ang pwede kong gamitan ng addition. Right? So that's why I needed the parenthesis there. And then I know that addition is associative, right? So ibig sabihin, pwede kong pagpalitan yung ordering. Instead of putting together a plus c, I can group c and negative c first. So I can add that first and add the result to a. Then I'm going to do the same thing on the right side. And again, there is another typo. Dapat ito ay may plus. Yeah. So yun yung maganda sa live sessions, no? Na nako-correct natin itong mga to. So yeah. So the reason here is by associativity of addition. Okay. And then now to the next line, we have c plus negative c. So we know that negative c by notation is the additive inverse of the number c. So when I add negative c to c, I'll get the additive identity, which is 0. All right. Same thing goes on the right side. So here the reason is by property of additive identity. Oh, sorry, additive inverses. Okay. And then we have a plus 0, but we knew 0 is the additive identity. So when we add 0 to any real number, we get that real number back. So a plus 0 is just a, b plus 0 is just b. So here the reason property of the additive identity. Or you can say that 0 is the additive identity. Okay? And we're done because we have derived the thing that we wanted to show earlier. All right? And then from now on, you can appeal to the cancellation law for addition. No need to prove it every now and then. Pwede nyo nang gamitin yung cancellation law for addition. Okay? So, any question on that proof? Pag binigay ko ba sa prob set yung theorem 1.2, kaya nyo nang sagutan?
Sir, may tanong po ako.
Oh, sure. Go.
Kunwari po, itatry ko pong i-prove tong Theorem 1.2. Is it still necessary na isulat ko po itong mga A4 and mga properties na ginamit ko per line? Or pwede pong katulad lang po nung nakasulat sa initially dito sa proof?
Yeah, that's a good question. Sa simula siguro, mas okay na isulat nyo siya. I will appreciate it if you will put the reasons behind. Pwedeng hindi yung mismong number. Pwedeng sabihin nyo lang yung keywords. Diba? Instead of A4, you say, ano ba yung ginamit? Ano yung A4? Existence of additive inverse. So okay na yun. Para makita ko lang yung thinking process nyo. Pero when we go later, ida-drop na natin yung mga reasoning sa proof pag nagsusulat na tayo ng paragraph 4. But I will greatly appreciate if you can include these tiny details. At least for now, at the beginning of the class. Right?
Okay po. Thank you po, sir.
All right, you're welcome. Any other question or clarification? Wala naman, so okay lang na exercise yung Theorem 1.2. Okay. Napaka-similar nung proof, so I think we can skip that. Here are some nicer exercises. So Theorem 1.3, a bunch of properties of addition and multiplication. So for instance, Here, the assumption is that we have three real numbers, A, B, and C, and then we assume that A plus C equals B plus C. Bakit ko siya kailangan? Inisip ko kung kailangan ko nga ba siya. I don't know if I need this assumption. So let me just mark this as red and put a question mark on it for now. I don't know if I will be needing that in any of the problems. Actually, kanina pinifigure out ko rin yung ano yung ibig sabihin ng number 3, but I don't seem to remember what that c to the negative 1 equals 1 over c means. Kasi di ba yung c to the negative 1, yan lang yung notation natin sa 1 over c. So yung theorem 1.3.3, parang restatement lang parang restatement lang nung notation. Pwede ko siyang palitan ng ibang theorem, pero let's see. Inisip ko pa kung para saan siya, pero I don't think there is any meaning to it. So burahin ko na lang siya for now. Unless you have an idea. So, yeah. Ito yung mahirap na hindi ako yung nagsulat ng materials. So minsan makikita niyo may mga i-edit ako along the way. But yeah, kindly also edit it on your work, on your copies. So let's see. Let's try to prove some of these. Nagte-take down notes ba kayo? Kasi I'm thinking, i-upload ko ba tong annotated version, or it's fine if you write it on your own? Kasi if it's fine that if you think I don't need to upload this, pwede ko nang isulat dito yung proof, tas buburahin ko na lang para magpo-prove na ako ng susunod. Or I can add another page to this PDF, tas doon ko isusulat yung proof. So what do you think? Pero mas gusto ko nag-take down notes kayo. So, pero what do you think? Bahala kayo pag hindi kayo nag-react ako ang pipili. So, dahil wala nagre-react, I will do the proofs on the side and just erase it when I start proving the other. So, hopefully you are taking down notes. Anong gusto niyong i-prove? So, let's see. The first statement is something that is very obvious, that sometimes yung pagiging obvious niya, yun yung nagpapahirap para i-prove siya. All right? So because this is just telling us that a times 0 is equal to 0, but we know that from elementary. But the problem is I invoked the meta-axiom of ignorance earlier, so we cannot use that fact from elementary. So kailangan ko talagang i-establish muna ng a times 0 ay equal kay 0. So let's try to write a proof for it. So here, okay, so proof ng number 1. Okay, so we know the only thing that we know here is a is a real number. So probably I can write that a is a real number. Then we want to show that a times 0 is equal to 0. Okay. Now where should I begin? Well, since I am proving an identity, I'm proving an equation. You have two options. You either start on the left side and try to derive the right-hand side, or start with the right-hand side, use logical arguments in order to show the left-hand side. But I think it's easier to start with a more complicated side kasi dun tayo mas maraming magagawa. So probably here I'll start with a times 0 and hopefully use some properties of multiplication and or addition in order to show that that will simplify to 0. Okay? So now I'll start. Note that a times 0 is equal to what? So I want to eventually have a statement that will lead me to the statement that this guy is equal to 0. Okay? Now, ano ba yung alam natin? A is an arbitrary real number. So I cannot do much about that. Okay? But how about 0? 0 is the additive identity, right? So parang mas marami akong magagawa kay 0 kasi mas marami akong alam tungkol kay 0. For instance, it's the additive identity. And the additive identity can be obtained by adding a number to its inverse. So basically, I'll try to bank on that idea. So I'll have A. Since it's arbitrary, I cannot do so much about it. I'll go to 0. I know that 0 is the additive identity. So I can just say, I can write that as B plus negative B. Right? For any real number B, right? So B is any real number. Okay? Pwede nyo rin pilihan A na rin kasi ang A plus negative A ay 0 rin naman. So you can express A by any number, or you can write 0 as 1 plus negative 1, right? Or 1 plus the additive inverse of 1, which is fine however you get 0. Okay? And then, meron ako ditong multiplication by a number and a sum. So I can apply the distributive property of multiplication over addition. So I can write it as, or actually, naka-problem pala ako. Kasi mangyayari maging AB plus A times negative B. Tapos dito na ako ma-stuck. Kailangan ko yung Theorem 4. So, yeah. I need this result in order to prove this one. Let me think a little bit. Meron pa akong pwedeng gamiting ibang way para makuha to. So you see what my problem is. I have this as AB. Then I have here A times negative B. But I don't know how to multiply A and negative B yet. I don't know that the answer is negative AB. Hindi ko pa siya alam kasi hindi ko pa siya na-prove. Actually, that is which statement? That is statement, parang nasa statement 6 pa lang siya. So, yeah. Any suggestion? Unless ipoprove ko muna yung prerequisite.
Too much Harry Potter?
Any suggestion? Bakit kaya siya yung nilagay na una? Nilagay siyang una kasi dapat may mapoprove natin siyang unang-una. But here, it seems that my approach will require me to use other statements that were not yet proven. So let me see. Can you think of a remedy to this? Yeah, I think I will need some other results before proving this one. Specifically, oh yes.
Naisip ko po, gamitin po yung A5, yung commutativity for AB and A times negative B para po maging BA siya minus B plus negative BA. Paano po ba yun?
Well, you're suggesting gawin ko siyang BA plus negative BA. Tama ba?
Opo.
Ang problema ko pa rin doon ay paano ko i-multiply itong dalawa? Yung negative times A, hindi ko pa alam na equal siya sa negative BA.
So
But
hindi,
I
hindi
think
po
you
pala
know
siya
what
pwedeng...
I'm trying to do. Yeah, pero yeah, at least na-imagine mo yung gusto kong gawin. Ito rin yung una kong naisip eh. Dapat masulat ko siya na BA plus negative BA para maging na-additive inverse si negative BA ni BA pag in-add ko siya 0 kagad. Pero ang problema, paano ko mapapalabas si negative BA? Kasi yung negative BA, additive inverse yan ni BA. Pero ito, product siya ng additive inverse ni B at saka ni A. And there's no theorem yet that will allow me to conclude that these two guys are equal to each other. fail kagad yung una kong attempt sa proof sa klase, no? Ano naman pala, third
sir.
theorem na natin to. CK, may suggestion?
Pwede sir, let CB equals AB.
C equals AB. Okay, kung gagawin mo yon, ito ay magiging C. No question about that. Pero ito, magiging negative C ba siya? Di pa rin tayo sure. Kasi hopefully nakikita nyo ngayon yung technicality ng notations. Ito ay A times B. So isa na siyang number, AB. Kaya lang, yung second term, product siya ni A at saka ng additive inverse ni B. So I am multiplying A by the additive inverse of B. But I don't have any tool yet that tells me that that product is equal to the additive inverse of AB. Kaya ngayon nag-iisip ako, ano kaya yung theorem pwede kong gamitin? Let me see. Pwede ko ba siyang dayain? Ito yung inisip kong proof kanina bago magklase. Tapos ngayon ko na na-realize, hindi pala siya pwedeng gamitin. Let's see. Okay, siya ay 0. Property 0. I-add ko siya sa kahit ano. So, I should get back... Yeah, probably I need to prove something first before tackling Theorem 1.3.1. Unless I am missing another approach, but it seems I need to at least prove Theorem 4 first before proving 1. So,
sir, pwedeng natingnan ko na yung problem last night. Let me know kung pwedeng i-share kung ano yung nakita kong solution.
Oh, go ahead, Carlo. Are you trying? Okay.
The solution that was given was to use the property of the additive identity. So yung 0, magiging 0 plus 0.
Okay. Oh yeah, probably that will work. Let's try that one. Thank you, Carlo, for saving the day. So bumalik ako mag-prove ng 4. Yeah, I see. Instead of a B plus negative B, they decided to use, okay, I think that will work. Instead of B plus negative B, pwede ko naman palang gawin na 0 plus 0 na lang, which is still fine, right? Because 0 plus 0 is still equal to 0 because 0 is the additive identity. So when I add 0 to itself, I get back 0. So that's still fine. So still property of additive identity. So property of additive identity. Okay. And then I will use the distributive property. Okay. So this is distributive property of multiplication over addition. Okay. And then let me just write this one out. Okay. And then what can we do now? Ayan, medyo malapit na tayo sa katotohanan. What do you think can we do next? Well, I can add 0 to... I can add a 0 here. Do you agree this is still good? Tama? Nagdagdag lang ako dito ng 0. Pero dahil 0 ay additive identity, it adds nothing or it changes nothing insofar as addition is concerned. So 0 siya dyan. Okay? Tapos, so this guy is still equal to this. Right? But what's the beauty of having this statement? So lagyan ko lang ito ng property of 0. additive identity. Okay. The beauty of that is I can use the cancellation law for addition. Because pwede ko nung i-treat as A, pwede ko itong i-treat as B, as C. Kasi ito ay B, ito ay C. So parang meron ako ng A plus C equals B plus C galing sa cancellation law. And that cancellation law tells us that if you have A plus C equals B plus C, the C's will cancel each other out, leaving us with A equals 0. Right? So that means in that sense, this will imply that 0, dahil meron ako ditong A times 0, meron din ako ditong A times 0. They are the same addends to both sides of the equation, so they will cancel each other out, leaving us with 0 equals A times 0. All right. And then I will use the reflexive property of equality to switch the position of the two sides of the equation, and eventually end up with what we wanted to prove. Okay. So is that okay? Thank you, Carlo, for suggesting that. Yun yung mahirap pag live, no? kung meron akong naisip beforehand tapos hindi pala siya mag-work. So yeah, thank you. At least you are part of the thinking process. At yun yung gusto ko sa spontaneous classes. So, I mean, kasama kayo dun sa thinking process at dun sa struggle ng pag-prove. But I greatly appreciate the suggestions, guys. So, yeah, maganda yung nagsasuggest kayo para mas makita nyo kung acceptable nga ba pag ganito yung ginawa nyo sa homeworks or sa problem sets. So, yeah. Okay, any questions? Wala naman. So, picturean nyo na siya kung kailangan nyo kasi i-delete ko na siya. Perhaps you can prove, oops, sorry. Perhaps we can prove another statement. Okay, 3, 2, 1, delete ko na siya. Okay, so ito ay, tanggalin din natin to. Any one item that you want to prove, maybe we can prove property 2, and then I'll leave the rest to you. Yeah, let's try property 2. So sa property number 2, ang gusto kong ipakita sa pagpo-prove ng property number 2 ay yung pagbasa ng symbols. So remember that the negative sign in front of a real number is just a notation for the additive identity. So if you are reading Theorem 1.3.2, you read it as the additive, ang kiniklaim niya is that the additive identity of A is equal to A. Hindi nyo siya pwedeng isipin as -1 times -A because this is a notation on its own. The additive inverse of the additive inverse of A is equal to A. And that's what we want to prove. And we will prove it in the language of the properties of addition and multiplication we assumed earlier. All right. So if I am to prove property 2, I'll do it this way. Okay. So again, at the back of my mind, what I want to prove is being additive inverses. So here I want to show, or we want to show, that what? The additive inverse of negative A is A, right? And remember, how do we show yung pagiging additive inverses nila? Kailangan nating ipakita na pag in-add natin silang dalawa, ang sagot ay 0. All right? That's exactly what we want to show. Okay? So that means I want to add A and negative A. All right? Pero parang super dali naman. Or may na-miss ba ako? Additive inverse ni negative A, right? So etong left-hand side, negative inverse ni negative A daw ay si A. So tama ba yung pagkaka-interpret ko? Tama naman, no? Additive inverse ni negative A ay si A. Yun yung gustong sabihin ng theorem. So in order to show that, or to show that negative A is the inverse of A, i-add ko lang si A at saka si negative A. Kasi gusto kong ipakita ang additive inverse si negative A ay si A. Perhaps the more correct way of writing it is that negative A, negative A plus A should be shown to be equal to 0. Okay? Pero ano nga ba to? I can use the commutative property of addition and write it as A plus negative A. But again, by one of the axioms earlier, actually the property of additive inverses, A plus negative A is just equal to 0, right? So this is equal to 0 by property of additive inverses. And so finally, dahil ang negative A plus A ay equal kay 0, I can say that the additive inverse of negative A is equal to A. So I can conclude that the additive inverse of negative A is equal to A. And that ends the proof. Okay? Medyo parang napaka self-evident nung statement. But basically, it's just a play on the ordering of the addition. Actually, medyo madaya nga kasi in-state na to sa property of additive inverses sa taas. Pero basically, if you want to see the detailed proof, here it is. Okay? And then if you have time, you can play with the rest of the problems. So if you will spend some time on it and find some difficulties in proving some of the statements here, you can let me know. Send me a chat or send me an email. Or kahit sa start ng meeting on Tuesday, you can let me know if you had some difficulties with some statements in this theorem. Okay? All right, any questions, comments, suggestions? Or wala kayong reaction? Or nakatapos na ba kayo ng isang episode dyan? Wala talaga? Walang reaction? Okay, so let me continue then. Remark 1.2 simply defines exponentiation as what we have done before. If you have a positive integer as an exponent, it will just tell us how many times do we want to multiply a real number to itself. So x squared is multiplying x to itself 2 times. X cubed is x times x times x, and so on. If you have a negative exponent, so ngayon pa lang nating bibigyan ng meaning ano yung ibig sabihin ng x to the negative 2. Kasi yung x to the negative 1, alam na natin, ibig sabihin niya ay multiplicative inverse. Pero yung x to the negative 2, wala pa siyang meaning. Pero now we can give meaning to x to the negative 2 by defining it to be the square of x to the negative 1. Actually, hindi nga pwedeng tawagin siyang square kasi wala pa tayong notion ng pagiging square. Pero thankfully here, we have said that if we have a positive integer as an exponent, that tells us how many times to multiply the base to itself. So, yung pag may negative exponent ka pala, kunin mo lang yun to the negative 1, tapos kopyahin mo dito yung exponent. And then you will use the definition of a positive integer being the exponent, and say this is x to the negative 1 times x to the negative 1. So meaning you multiply the multiplicative inverse of x to itself twice. Of course, provided x is not equal to 0, because x inverse will not exist if x is equal to 0. Kasi si 0 walang multiplicative inverse. Siya lang yung katangi-tanging real number without a multiplicative inverse. Okay? And then if you have a rational exponent, rational exponent, so we define it this way using the usual notion that we know. Of course, hindi masyadong rigorous yung pagkaka-define ng exponentiation, but I hope you get the idea. This is the same notion as the usual exponentiation that we know. All right. And that wraps up section 1.2. Okay lang ba yung pacing? Masyado bang mabilis? Masyado bang mabagal? I hope the pacing is okay. All right. So just let me know kung masyadong mabagal or masyadong mabilis. Okay. So let's go to 1.3. Kakarami tayo ngayon but I'll try to finish until page 9. So marami-rami pa. So some important sets of real numbers. So we have the set of natural numbers. You know this from Math 101. The set of integers being the negative of natural numbers. Actually, kukulangin pala to, no? Dapat kasama si 0. Okay, kindly put that there. Kasi sa first bullet, hindi ko sinama si 0. So, ibig sabihin, kung i-define ko yung integers to just be the number such that itself or its negative is a natural number, then hindi mapapasama si 0. So, i-union natin si 0 kay z para lahat na ng integers ay kompleto na. And then the set of rational numbers is the set of all ratios of integers, provided that the denominator is not equal to 0. So, these are still your usual notion of the sets or the subsets of R. Okay. Now, remark 1.3 tells us that a real number is irrational if it is not rational. So basically, this just tells us that Q complement is just the set of real numbers minus the set Q. So lahat ng hindi natin kayang i-express as a ratio of two integers is an irrational number. Okay? And your theorem 1.4, root 2 is not rational. That is, the square root of 2 is an irrational number. Actually, isa tong malaking probably one of the fundamental discoveries in ancient Greece, because for a good portion of time, the Greeks believed that all numbers are rational. And then here comes, I think it was Hippasus. Kindly check on that, fact check me on that. There's this guy who said, square root of 2 is not irrational. It's not rational. And then parang tabu sa kanila yon kasi feeling nila all numbers are rational because we always think that everything in the universe is well structured. So yun yung nasa isip ng mga Pythagoreans or ng early Greeks. And then this guy was executed according to legend, though I don't know if that is true. According to urban myth or legend, he was killed for spreading the word that square root of 2 is irrational. But apparently now we accept that square root of 2 is not rational, and we have a proof telling us that exactly here. Now let's read the proof and try to understand the reasoning here. The good thing about this proof is it's another type of proof, and this is proof by contradiction, or an indirect proof. So this is one of the methods of proof covered in Math 101. So in an indirect proof, we will assume the negation of the statement to be proven and show that if that is true, then something will be fatally wrong. So ganun yung nagwo-work yung indirect proof. So dahil dito, ang gusto nating ipakita ay irrational si square root of 2. Okay? Then if we will do an indirect proof, we will assume or we will start our argument by assuming that this is false. So proof by contradiction, we will suppose that square root of 2 is rational. Okay? So basically what we want to show is that root 2 is irrational. Okay? And then if I am doing a proof by contradiction, I will suppose that that is wrong. Meaning I will assume that Q is a rational number. I usually use the dollar symbol para sa supposing something for the sake of contradiction. So here I am supposing for sake of contradiction that root 2 is rational. Dahil hindi naman talaga ito yung gusto kong i-prove. Ang idea sa proof by contradiction, kunwari totoo to, or kunwari mali yung theorem na gusto kong i-prove, then kung mali yung theorem ko na ipuprove, guguho yung foundations ng math. Meaning there is another truth that will be violated or contradicted. So yun yung idea niya. So let's see what is contradicted. So suppose, i-accept natin na si root 2 ay rational. O, kunwari rational siya. So ano ngayon? Papakita natin magkakaroon tayo ng problema. Magkakaroon ng conflict with something that we know to be true. Okay, let's go back to the proof. So yun yung contradiction proof. So here we suppose that root 2 is rational. So kung rational siya, ibig sabihin, I can write it as a ratio of two integers. So that means root 2 can be written as m over n for some integers m and n with n not being equal to 0. So dahil fraction to, I will assume na pwede ko siyang i-lowest terms. So if I will divide m and n by their greatest common factor, meaning naka-lowest terms na siya, so si root 2, pwede kong tingnan as m star over n star. Okay, so si m star over n star ay yung siya yung lowest term ng m over n. Para lang, wala nang common factor si m star at saka si n star. Wala na akong pwedeng i-cancel mula sa taas at saka sa baba. Okay? Which is perfectly fine, right? We can do taking the lowest fraction for any fraction or the lowest term for any fraction. Okay. Now, what do we get? Okay. So kung ito ay totoo, pwede akong gumamit ng multiplication property of equality and write this as m star equals root 2 ng n star, right? Usual multiplication property. Multiply ko to multiply ko to ng n star, multiply ko to ng n star. Remember, division is just multiplication by the inverse of n star. So, makakancel yung n star, matitira si m star, pero yung right-hand side magkakaroon na ng n star. And then, since these two guys are equal to each other, I can multiply both sides by themselves again and come up with an equality. Dahil equal naman silang dalawa, pwede kong i-multiply yung sarili nila sa parehong sides to get another identity. So if I will do that, we will get this guy. Or kung gusto nyo tingnan siya from Math 17 point of view or from high school algebra, squaring both sides of the equation. Okay? And that's how we got this. Okay? And then this is telling us that m star squared is even. Agree? Itong equation na to, sinasabi niya even si m star squared. Kasi si m star squared ay equals to 2 times another integer, right? And remember, an integer times 2 is also even. So even siya, all right? Now, here is our claim. Yung claim ko, si m star ay even din. Yun yung gusto kong ipakita. Okay? Now, paano ko mapapakita na si m star ay even? But I hope you don't get lost in the process. I am trying to find a contradiction. So far, wala pang contradiction. Lahat ay maayos pa. Wala pang gumuguhong foundation ng math kung totoo na si square root of 2 ay rational. So I'll keep on digging and try to probe this a little bit more. And now, I see that m star squared is even. Tapos, i-claim ko, si m star dapat even din. But I need to prove that. Okay? So I have another proof within the proof. I want to prove that m star is also even. And I will do that again by contradiction. So I'll do that by contradiction by saying, kunwari, si m star ay hindi even. So dapat odd siya. Kung odd siya, si m star, pwede kong isulat na 2k plus 1 for some integer k. Tama? Kasi yung mga odd ay plus 1 lang sa mga even. Alright? So pagka in-square ko both sides, makukuha ko si m star squared. But if I square this guy, okay, makukuha ko ay 4k squared plus 4k plus 1. Tapos I can group the first two terms together. I can factor out the 2. So I'll get 2 times 2k squared plus 2k plus 1. And what can you say about this number? Is it odd or even? So I hope you see that this number is obviously odd, right? Kasi meron kang even plus 1. So this is odd. So that means M star is odd. Pero this is a contradiction. So I use a Harry Potter arrow for contradiction. So this is a contradiction because we already knew that M star squared is even. So that means kung totoo na si M star ay odd, dapat odd din si M star squared. But we already know that M star squared is even from our earlier result. So to maintain consistency with this system, we want to conclude, or we should conclude, that M is even. Kasi kung odd siya, mali na yung na-derive natin kaninang truth. So guguho na yung argument natin. But to keep this argument intact, then that means we are forced to assume that M is what? M is even, or M star is even. Okay. Now we have established that M star is even, so that means M star is equal to 2p. Okay, for some integer p. So even siya, so 2 times something siya. Okay. Now we can square both sides again, and we get 4p squared equals M star squared. Okay. But M star squared, if you remember, is equal to 2n star squared. So ibababa ko lang to, papalitan ko siya doon. So ibig sabihin, si 4p squared ay equal kay 2n star squared. And then I can divide both sides by 2 and arrive at this statement. 2p squared is equal to n star. Okay so far? So what can we say about that? So we can say here that n star actually is even. And I will say there is a contradiction there. Can somebody tell me where what is the contradiction? Mukhang makakaligtas kayo sa homework, no? Kasi hindi ko natapos. Ang daldal ko kasi mag-discuss. So anybody? Why do I say there is a contradiction now to my original assumption that root 2 is even? Sorry, is rational.
Tapos sa GC namin, may GC kasi kami ng
So
mga
yung
teacher.
contradiction po na nakita is yung inasyon po, na-prove po kasi natin na yung M star is even. So therefore, yung M star square is even. And then this po, dito naman po sa may last part, nakita po natin na yung N star square is also even dahil po sa 2p square. So therefore, dahil pareho po silang even, meron po silang common factor na 2. So therefore po, hindi pa po nasa lowest term yung M star over N star.
Okay, great. Thank you for that. Exactly. So can I know your name? Hindi ko kasi makita, sorry.
Christine Tan po.
Okay, thank you, Christine. Yeah, sorry, hindi ko nakikita sa monitor kung sino nagsasalta. But yeah, Christine is perfectly correct. Na yung contradiction ay dun sa pagiging lowest terms ni M star over N star. Because remember, we have shown that both M star and N star are even, right? So yun yung meron tayo. Pero that cannot happen because if they are both even, then meron silang common factor. Parehong factor nila si 2, which is a contradiction to what we have stated earlier, that M star and N star have no common factors anymore because of the assumption that we have taken the lowest terms. So if we will accept the fact that si square root of 2 ay rational, kung i-accept natin yan to be true, then makakakuha tayo ng fraction na nasa lowest term niya na at hindi pa nasa lowest term niya. So hindi naman pwedeng wala siya sa lowest term at nasa lowest term na siya at the same time. So therefore, we must reject the supposition that root 2 is rational, leaving us with only one choice, but to accept the theorem to be true, that square root of 2 is an irrational number. Okay? So does the proof make sense? So this is one of the classic results. I think you already seen this in some of your courses, other courses, but it's nice to remember these classic results, okay? And it's a nice example of proof by contradiction, okay? Any other questions? Wala pa naman. Mukhang makakaligtas talaga kayo. Nag-lag kasi ako dun sa a times 0 is equal to 0. Yan tuloy. Hindi ko matatapos yung coverage, so I might be forced to move the deadline for homework 1. So I promise to give you a hint. Okay lang ba i-move ko yung deadline to when? When is the original deadline? The deadline is on the 20th, tama nga ba? Tama no, sa Monday dapat. Pwede bang gawin nating Wednesday na lang? Okay lang ba 'yan sa 20, 21, 22? Gawin natin sa 22 para makapag-discuss pa tayo sa 21. Tapos magawa nyo pa siya after or during the class. Okay lang ba 'yon? Or do you need more time than the 22nd? Okay, chance nyo na to. Kung hindi, magsaset ako ng deadline. Bahala kayo. Wala talaga, guys. Come on. Kapalan nyo na yung mukha nyo pag-request ng extension. So, more time, okay. Buti na lang nandyan si John. Meron kayong alay sa pagsasuggest. Friday? Sige na nga, Friday. Friday, anong date ng Friday? Friday is on the 24th. So I'll move the deadline to Friday. Kailangan ko siyang i-note kasi baka makalimutan ko. September 24th. Okay. Pero so far, hindi ko muna i-move yung deadline ng next homework, which is on the 27th. Depende na lang kung anong mangyayari next week. All right. So, maybe I can say something about that na rin para for the sake of those who wanted to start early. Kasi 1 minute na lang naman and I don't want to rush discussing. At I hope okay lang yung ganitong setup. Mas gusto ko kasi yung spontaneous kasi yung may PowerPoint ako na pindot lang ako ng pindot para makita nyo rin yung thought process. So pati yung usually improving, gusto ko rin ginagawa siya ng live para at least part kayo nung reading, part kayo nung thinking process. Though yun nga, kumakain siya ng time. But I don't mind being slow in covering topics as long as you understand what is being covered. Okay. So if you want to go ahead and try homework 1, though again, the deadline is extended on the 24th, Friday next week. Probably lagay ko na lang din ng 5 p.m. on Friday. Okay, 5 p.m. next Friday. So, okay. I cannot say anything about number 1 yet because we haven't introduced the topic of the order axioms. Okay, pero ang gusto niyo lang sabihin na hindi na order or hindi natin kayang bigyan ng order yung set of complex numbers. So a couple of sentences, 2 to 3 sentences will do for problem number 1. Explain nyo lang, no detailed proof needed. Kwento nyo lang sa akin bakit hindi siya kayang i-order. Okay. So kung walang order, bakit? Bakit walang order? Okay? And then for problem number 2, sino nagsabi kanya? I think somebody from the class said medyo mahaba yung proof, right? So but in this case, I won't require you to have a very detailed proof because you just need to find the infimum and the supremum of this set A. Hindi ko kailangan ng formal proof. Kailangan nyo lang ikwento bakit yun yung naging conclusion nyo. So I don't think you'll have a problem with the question A kasi substitution lang yan. Ano yung unang 5 elements ng set? When I say unang 5 elements ng set, gawin nyo lang n equals 1, n equals 2, until n equals 5. Computin nyo yung 5 numbers na yon, makukuha nyo na yung sagot sa A. So I hope that won't be any problem. All right? So papalitan nyo lang yung upper limit ng summation. So you'll find 5 numbers. You can use a calculator, you can use a spreadsheet, you can use whatever resource you have to find the 5 elements. Hindi ko hanapin yung mano-mano yung solution. So sabihin nyo lang, the first 5 the elements of A corresponding to n equals 1 until n equals 5 are the following. Pwedeng naka-fraction, pwedeng naka-decimal, tapos lagyan nyo respectively. So yun na yun. Hindi ko kaya hanapan ng detailed solution para doon. Okay? And then, kaya ko siya nilagay Kasi para maging clue siya dun sa second part ng question. Because the second part of the question asks about the infimum and the supremum of A. On Tuesday, we will learn what the infimum and supremum are. But basically, pwede nyo tingnan, pwede nyo isipin na yung infimum siya yung greatest lower bound at yung supremum ay least upper bound. So, kailangan nyo siyang ibigay, pero kailangan nyo ikwento sa akin bakit yon yung nakuha yung infimum at supremum. Okay. One way to argue this is, halimbawa, pwede nyo sabihin, sir, napansin ko yung set A, increasing yung elements niya. Pero I would love to see, why did you say na increasing siya? Okay? So kung increasing siya, sabihin nyo kung bakit nyo napansin na increasing siya. Hindi pwedeng sabihin nyo lang na, sir, kasi yung increasing yung unang 5 elements na kinompute ko sa A. That is not sufficient or justification na increasing siya. Kasi baka sa dulo ng list, pag hindi nyo na-establish yung pattern, baka makita nyo na hindi naman pala siya increasing sa dulo. So, pwede nyo ikwento kung bakit sa tingin nyo siya ay naging increasing. Okay? Makikita nyo yung process kapag ginawa nyo to ng mano-mano. Pag ginawa nyo yung part A ng mano-mano, o ginawa nyo siya carefully, makikita nyo kung bakit increasing yung set, yung elements ng set pag lumalaki si n. So pwede nyo sabihin, okay sir, ganito siya, increasing siya. Increasing siya kasi ganito. So dahil increasing siya, yung pinakamaliit niyang lower bound, ibig sabihin ay yung unang element ng set o yung pinakamaliit ng element ng set. And we will learn later that if you have a minimal element or a minimum element in the set, kung may pinakamaliit na element yung set, siya na rin yung infimum. So you can answer the infimum right away. Okay? And then sa supremum naman, tingnan niyo yung pattern. Kung hindi niyo pa makita yung pattern galing sa sagot niyo from part A, you can extend your solution. Gumamit kayo ng Excel o ng programming language para makita ano yung nangyari pag n equals 6, n equals 7, n equals 100. Ano yung mangyari? Lumalapit ba ako sa isang number? Kasi matututunan natin later na kapag meron akong increasing sequence of numbers, in the long run, magko-converge siya sa isang number. Palapit siya ng palapit sa isang constant. At dahil increasing yung number, so meron kang number, ito yung n equals 1, ito yung n equals 2, n equals 3, n equals 4, n equals 5. Tapos sabi nyo, increasing siya, so pataas ng pataas yung values, and 100 halimbawa to. Pero makikita nyo, palapit lang siya ng palapit sa isang wonderful constant. So palapit lang ng palapit yung term sa isang constant. Ibig sabihin yung constant na yon, siya malamang yung supremum. Kasi siya na yung pinakamaliit na upper bound para dun sa elements ng set. Ibig sabihin, walang lumalampas dito at wala ng upper bound na mas liliit pa dito sa constant na to. So, yun yung hahanapin kong reasoning. Hindi nyo pa pwedeng sabihin na kapag meron ng increasing sequence, mag-converge siya sa supremum. Kailangan pa nating i-prove yun. Pero intuitively, you can find this constant by simply arguing, sir, I noticed that the set is increasing. It is increasing towards a constant. So that means intuitively, that constant to which the terms converge should be the least upper bound or the supremum. Okay? But again, we'll learn more about the infimum and supremum on Tuesday. So that's why the deadline, thank you to Angelo, is extended until Friday the 24th. Okay, 5 p.m. on Friday the 24th. I'll change it on Canvas probably tomorrow. I'll just need to leave right after our meeting. Any other questions? How do you feel about our first meeting? Okay lang ba? Okay ba sa inyo yung ganitong setup?
Okay po, sir.
Okay. All right. So, yeah. Paling pangit kay Teams. Pag may nagchat-chat, nag-notify siya tapos natatakloban yung bagong mga messages. Okay. Thank you for the feedback. So, any question Meron pa ba kayong mga i-aapila? Wala pa naman? Okay, so kung wala na, then I think that's it for today. Thank you for joining the meeting, and I hope to see you guys again on Tuesday. What else? So again, homework is moved. All right, so I think that's it. So have a good day, everyone, and let's meet each again. All right, keep safe, guys. Oh, enjoy the
Thank you,
weekend.
sir.
Thank you po,
Holiday
Thank you po,
bukas.
sir.
So, may pasok ba kayo bukas? Holiday sa Las Bañas, di ba? So, kailangan nating i-observe yung holiday. So, hindi ako magta-klase bukas dun sa iba kong klase. So, hopefully other classes ay hindi rin nagklase. So, you have the Friday off to relax a little bit. All right, bye guys.
Bye, sir.
Mm-hmm.